Welcome to the MecSoft User Spotlight Series, where you can find real customers achieving their success with MecSoft products. Today we'll be spotlighting Hancock Central School in the use of VisualCAD CAM CNC software. Hancock Central School is located in Houghton County on the Keweenaw Peninsula of Upper Michigan. The HCS Bulldog mascot represents the tenacity of the town's early immigrants who worked the deep shaft mines in the area. Today, the school offers students hands-on woodshop, metalworking, welding, and drafting classes. More recently, a CNC machining class was added for some of the more advanced junior and senior high students. Doug McIntosh is a retired SurfCam user and toolmaker from Ford Motor Company with 30 years of experience in the trade. Today, Doug works with Gary Mishika, the HCS Industrial Arts teacher, as a volunteer instructor, introducing CNC machining and the fundamentals of G-code programming to a small group of dedicated HCS students. We recently sat down with Doug to discuss the HCS Bulldogs and to learn how VisualCAD CAM from MecSoft Corporation is being integrated into the HCS curriculum. The VisualCAD CAM difference. For the past 2 semesters, Doug has been slowly integrating VisualCAD CAM from MecSoft Corporation into his class curriculum. Students first learn the basics of programming G-code manually from simple VisualCAD drawings. In the school's upcoming semester, Doug will be introducing the VisualCAD CAM Art and Mill modules into the metalworking class. The class boasts a complete foundry where students learn the basics of sandcasting molten aluminum. Students can choose from many aluminum casting projects. The HCS Bulldog mascot and the Nashville Predators mascot plaque project are illustrated here. Here is some of what Doug had to say about VisualCAD CAM.
About VisualCAD CAM, I really like it. I started off using Fusion 360, and I absolutely hated it. So I started looking around on the web and I come across you guys and tried out your trial program and really liked it. My vast experience with CAD CAM, as you know, was with SurfCam when I worked for Ford. I find the VisualCAD CAM 5,000 times easier than SurfCam. It makes a whole lot more sense. It's real easy to draw in. It's real easy to machine in.
Thanks, Doug. The HCS Bulldog in sandcast aluminum. In this project, a proof of the HCS Bulldog plaque is first machined from cherry wood stock, measuring 8 inches by 8 inches by 1/2 inch thick. A positive mold core is then machined from 6061 aluminum. The core is then used to press a hollow cavity into sand that has been treated with a strength bonding agent. The core is then removed, leaving a negative cavity. The cavity is then filled with molten aluminum that is left to cool. The base of the 1/2 inch plaque is the parting line of the casting. The CAD geometry. The CAD geometry for this project includes both 2D and 3D geometry. To begin the process, a 2D vector drawing of the HCS Bulldog is created from the mascot image file. This can be done in VisualCAD by loading the picture file as a background image and then drawing border and detail curves over the image like a template. Lettering and various diameter curves are also added. The resulting 2D drawing is shown here. A 3D cylindrical extruded base and raised letters are also added using VisualCAD commands. Raising the HCS Bulldog in Visual Art. The raised 3-dimensional mesh representation of the HCS Bulldog is created in VisualCAD CAM Art, also called Visual Art. This is a free module that is included in MecSoft's VisualCAD CAM and RhinoCam softwares. Using Visual Art, the 2D drawing is transformed into a raised 3D mesh using the Create Puff Volume command. Here on the left, we see the Art browser with the project tree and the puff operation listed. Also on the left, we see the puffing operation dialog. The Parameters tab of the dialog allows you to set the puff type, the height, and smoothing controls. The Relief Curves tab allows you to specify the perimeter border curves as well as interior detail curves used in the puffing operation. A close-up of the puffing operation is shown here. All border and detail curves lie on the XY plane. During the puffing operation, the space between each detail curve is given a volume and then raised upward in the positive Z direction. The greatest distance between detail curves is raised to the full height specified for the operation. The HCS Bulldog Mill Setup. Once all 2D and 3D geometry is created, you can then proceed to the mill module, where toolpaths are created and the G-code posted that will run the new CNC machine at Hancock Central School. In the left side image, we see the resulting cut material simulation of all toolpaths in the HCS Bulldog machining job. On the right, we see the machining job tree with each toolpath strategy listed in the order it is performed. The work 0 is located at the top center of the stock geometry. 3-axis roughing and finishing toolpaths. The machining job begins with 2 3-axis horizontal roughing toolpath strategies to remove excess material. The first removes material from the top of the stock down to the top of the lettering using a 1/4 inch diameter flat end mill. This toolpath is contained to the outer perimeter diameter of the base of the plaque. Step minimization is enabled, allowing the single toolpath to serve as both a roughing and then a re-roughing operation. The toolpath and cut material simulation are shown here. The second 3-axis horizontal roughing toolpath begins at the top of the lettering and ends at the bottom of the lettering and uses a 1/8 inch diameter by 3-degree taper or V-mill. The toolpath is also contained between 2 concentric 2D circles that lie on the XY plane. Each letter is located between these 2 concentric circles. This operation removes a total of 1/8 inch of material in Z. With a stock allowance of 0, this is considered the finishing operation for the lettering. We should note here that this project is illustrated using the VisualCAD CAM standard configuration. In the professional configuration, this second roughing toolpath can be replaced with a 3-axis horizontal re-roughing toolpath that calculates the required stock to remove from the previous cut material simulation, saving considerable machining time. The third operation in the machining job is referred to as 3-axis spiral machining. It is one continuous toolpath motion that begins at the center of the bulldog and spirals outward by an offset distance that is 50% of the cutting tool's diameter. The outer perimeter curve of the bulldog is used as containment for this operation. The cutting path is shown in the left side image. The resulting cut material simulation is shown on the right. 2 1/2 axis detailing toolpaths. The remaining toolpaths in the machining job tree consist of 2 1/2 axis profiling, pocketing, and chamfering operations. The first profile cuts the outer perimeter in 2 levels. The second profile cuts the outer shelf in 1 level at 2 step-over passes. The pocketing operation cuts between the outer perimeter of the bulldog and the inner circle perimeter of the lettering. The last 4 operations in the machining job tree are 45-degree chamfer toolpaths. These include the upper outer perimeter, the inner and outer lettering diameters, and the outer perimeter of the bulldog. The completed cut material simulation with these detailing operations is shown here. Now, sit back and enjoy the cut material simulation of the HCS Bulldog from Hancock Central School. The Predator's plaque in sand cast aluminum. This project begins with a VisualCAD drawing representing the Predator's outline and detail curves, as well as additional perimeter and containment curves. Similar to the HCS Bulldog, the machining job tree and resulting cut material simulations are shown here. The art and mill workflow illustrated in this video is discussed in greater detail in our two-part tutorial on the MecSoft Tech blog. You can find it at mecsoft.com/blog. To read this and other exciting case studies, we invite you to visit mecsoft.com/case studies. To learn more about Hancock Central School, we invite you to visit them online at hancock.k12.mi.us. To learn more about each Visual Mill feature and to download a demo, we invite you to visit the Visual Mill product page at mecsoft.com/visualmill. This video was brought to you by MecSoft Corporation, your CAM partner.